Hello class, today we'll learn about Lewis structures. Now what are Lewis structures? Lewis structures are just a way of representing molecules but with some details, and those details are all the electrons. So we show molecules with all their electrons, both bonding electrons and non-bonding electrons. Let's take an example. H2, this is the hydrogen molecule. And notice that there is only one line between the hydrogen atoms. That line represents 2 electrons in the bond. So this is called a bonding pair. Here's another example. Cl2, the chlorine molecule. Here, not only do we have the bonding pair, which is that line between the 2 chlorines, but we also have a bunch of dots around each chlorine. Each one of those dots is a single electron. So we can see that we have 3 pairs of valence electrons around each chlorine atom. Now both this and this are Lewis structures. Question is, how do we draw Lewis structures, especially for more complicated molecules? Well, this is how. We need to follow a certain number of rules. For the rest of this slide, we are going to show both the rules and how they work. So let's do that. To the right of this vertical line, we'll have an example that shows us how things work. And to the left, this area, we'll have the rules. So step number 1, it says that we need to find the total number of valence electrons, and from that find the number of pairs by dividing the total number of valence electrons by 2. Let's see how that works. 5 valence electrons for phosphorus, and 3 times 7, because we have 3 chlorine atoms, and each one of them has 7 valence electrons, so we get a total of 26. We divide that by 2 to get a total of 13 pairs. So now that we have determined the total number of pairs, what we need to do next is figure out what is the central atom, because we have a total of 4 atoms here, 1 phosphorus and 3 chlorines. We need to know which one goes in the middle. The rule says that the central atom has to be the least electronegative one, except for hydrogen, because hydrogen can only bond once. So hydrogen is always a peripheral atom. In this case, though, if you remember the rules about electronegativity, you know that phosphorus is less electronegative than chlorine. So phosphorus goes to the middle, and we have 3 chlorine atoms as peripheral atoms. Notice these red bonding pairs. So we have used 3 bonding pairs, and we need to subtract that from the 13 pairs. So now we have 10 pairs left. Keep that in mind. We'll see what we do with them in the next step. Next step says divide the remaining pairs equally over the outer atoms. So we had 10 pairs left. We divide them over the peripheral atoms, and we can see that each one of them should get 3 pairs. So 3 times 3 is 9. We still have 1 pair left. What do we do with that pair that's left? This is what we do with it. We place it on the central atom, as you can see here. Now this is looking pretty good. We are almost done. The only thing that's left to do now is to check for the octet rule, to make sure that every atom has 8 valence electrons around it. Octet rule, remember octet, 8. And here we can see that each atom has 8 electrons around it. So we're done. That's the Lewis structure for phosphorus trichloride, PCl3. Now that we have learned how to draw Lewis structures, I want you to try the next 4 examples. CO2, CO3 2-, HCN, and NH4+. Good luck, and see you in class.